Okay, welcome back. The topic of today is this little gadget that I've put together. This is the Utracer or Micro Tracer version 6. This is a kit available from Mr. Ronald Dekker from the Netherlands, and it's a curve tracer. Vacuum tube curve tracer or tube tester, well, I bought the kit from Ronald. It's a PC board with nicely laid out component bags and everything, very good descriptions on how to build it, and there's a large following on Groups.io. And anyway, so you build the basic PC board that has the outputs and everything, and you will have to supply your own box. And I bought this, I found this box on IKEA. It's a discontinued module. I do not remember, I think it was like plow furrow or something like that. And anyway, it suited with nice size to it. So I designed this front panel in Fusion 360, and I put, you can see a lot of tube sockets in there. So most of these tubes I have in operation in some of my receivers and transmitters. And I decided to go with the banana plug interconnect style. So these are the outputs from the tester, the anode or plate, screen grid, control grid, cathode, and these are the filament sockets. So basically what you do is you look at the data sheet, and you, like many octals, they have heaters on pin 2 and 7, so you just hook up the filament to pin 2, one of them, and the other to pin 7. So there you go. What else? Ronald's design has built-in heater supply, but I decided to make a separate, use a separate heater supply to be able to test battery tubes. So Ronald's design works, but at lower voltages it's not very precise. And I want also to be able to test, for example, a lot of the PL tubes, like the PL519. They use a 40 volt 300 milliamp heater, so I can adjust from basically 0 to 40 volts on this one. And what else? Well, it's not that much really. IEC connector here. This is the serial port that you connect to the computer with an RS-232 to USB adapter. And what else? Yeah, all the markings. This is a decal. I took the Fusion 360 design and took that, imported that into Inkscape, where I did all the lettering, and so it turned out really nice. I had a Swedish company here. They did this decal for me. It's like a heavy duty, quite thick material, so this should last quite long. And we're always bound to make mistakes, so I actually mirrored this this socket. This is for 807s and a couple of more. I actually mirrored these, and also this one, the Euro side pin socket. Those are mirrored, so I'll have to fix that later on. But anyway, we're gonna hook this up to the computer, and we're gonna test a few 807s, and we're gonna do a curve trace and compare that to the datasheet for the 807s. And we're also gonna do the quick test that is available. So I'm not gonna go into great detail with the software, with the UI, the Utracer UI, mainly because I haven't been playing with this that much. So yeah, that's it. I'm gonna hook up the tube and I'll get back to you. Okay, the 807 is the 807 is connected. Let's turn on the heater or the filament voltage. You can see that the current goes down. I think the heater current for the 807 is in the ballpark of like 900 milliamps. Like so, I'm gonna connect this to the computer. And we'll start the program. The filament has been heated. We can look at the load line for the 807 and the plate characteristics curve, and we can see here that this curve was taken with a grid number 2 volts of 250, so 250 volts on the screen. And let's look here. We will settle for like something that's even 400 volts at minus 5 volts on the control grid. So we can see our grid number 1 volts. This is at 0, but we'll go for minus 5, and we can see that this point is basically 400 volts minus 5 volts on the control grid, and we are expecting, what's that, 100, 110, 20, 30, 140 milliamps. So this is what the Utracer UI looks like. We're gonna begin by, I don't know if you can see this, hopefully you can see this. We're gonna ping the COM port. Okay, I got a good response from the microtracer or the Utracer to the computer, so the communication is all up. Then we're gonna choose the correct test, which is this one. Yeah, this is correct. So if you remember, minus 5 volts on the control grid, and we'll sweep, or we'll do a trace, so we'll stop at 600 volts on the anode, on the plate, and 250 volts on the screen. And so this is a remnant from the original Utracer heater supply. You can see this all counts down before the tubes are heated. It's not necessary in our setup here, so I'll just click that once more, and we are ready to test things. So we'll see what happens. It's got a nice beam tetrode, beam pentode response here. It doesn't have like the kink that the like the pentodes usually have due to the beam forming plates. But let's see, about 400 volts, 396.6 volts, 134.8, so 100, let's call it even, 135 milliamps. I would say that this tube is perfectly fine. This is how it looks like we got the correct response. I would say that this tube is absolutely just fine. We're gonna go for the quick test. So if you have a lot of tubes of the same kind, so I got this big box of 12A6. That's also a beam tube, and I have there's probably 15 of them. Just want to test them and sort them for future use. So this is what the quick test option looks like. We can switch between triodes and pentodes. I haven't experimented much with this, but I will probably do in the future. Anyway, from the data sheets we can tell that 140 milliamps was our kind of nominal value at 400 volts on the plate and 250 volts on the screen, and minus 5 volts on the control grid. We'll just hit test, and this test is much quicker. Like very much quicker. And we can see here that we got 134.71 milliamps at 392.7 and 251.7. We can adjust this a bit, but you know. So I'm gonna hook up another tube. So I'm gonna just roll over to the tester and take another 807. Okay, the filament is heated. So we're gonna test this one. So the last one we had 96%. And let's do another test with another tube. Same parameters, same everything, just a different device. So wow, this one is 104%. So 392.6 to 551.7, minus 5 volts on the grid, and we get 145.87 milliamps. So this one's quite the different response. The last one in and see which one's the best. Third, 807 is in place. Same parameters. We'll test this one as well. The last one was 96. This one was 104%. And we'll see where this one ends up. 83. Yeah, this is the slow one. Yeah, so quite clear results. I like this. So yeah, so I like this one. I'm very pleased with it. I need to fix those mixed up pins on the 807 and also on this Euro valve holder as well. Other than that, it seems to be working just fine. So thank you for watching. I'll probably do a follow-up video on this one by taking off the lid and show you what's inside, but it's basically just a printed circuit board, a computer, a laptop power supply, a small switch mode 40 volt power supply that feeds this this voltage regulator. So with that, I say thank you for watching, 73, and see you in another video. Thank you.